So welcome everybody to the Bitumen Beyond Combustion webinar. My name is Peter Baudouin and I'm a senior advisor with COSIA here in Calgary. This BBC study is an Alberta Innovates initiative, and Stantec was a selected consultant on the project. COSIA's interest is really that when we had reviewed the report, we figured it would really be of interest to the innovation community, hence the call today. So talking a little bit about, I'd like to introduce the presenters. We first have Axel Meissen, Senior Advisor with Alberta Innovates. We also have Nathan Ashcroft, who is a team lead from Stantec. And we have Paolo Bomba, Senior Manager with Alberta Innovates. So going over a bit of the agenda, we'll first start off with a discussion on BBC history and overview. The project was fairly multi-year project, so we've broken it down into a phase 1 overview as well as a phase 2. So we'll break those discussions up. We'll then move on to selected products, where we're going to talk about potential products where we see opportunities, and then we'll conclude with the next webinar. So the presentation should take about 30 minutes. If you do have any questions, please enter them onto the message system on the platform. And just for transparency, we will be recording this call and releasing it onto the platform after we complete the call. So we're now going to move to a local presenter. Paolo is going to kick off the next section.
Thank you, Peter, and welcome everyone to the webinar today, wherever you might be. My name is Paolo Baumann. I'm with Alberta Innovates. Alberta Innovates is the provincial research and innovation organization for the province of Alberta. And one of our mandates is to identify major challenges and opportunities that the province will face in the coming years, and then provide strategic guidance on those challenges and opportunities. And the Bitumen Beyond Combustion initiative falls within that area of interest. And so as we move forward and talk about Bitumen Beyond Combustion today, I first want to begin and talk about some of the growth challenges our world faces, because I think that paints a very interesting context within which to think about alternative uses for our bitumen. So global population has been increasing dramatically since the Second World War, and is projected to continue to increase out to 2050, projections of 9 billion people on the planet by 2050. And along with that, growing middle class has increased the demands on various goods and services, such as housing, transportation, and the consumer goods that supply those lifestyles. And so with that, there is an increasing demand for the materials that go into building these houses, transportation methods, and consumer goods. And so that's one important consideration to think about in terms of this initiative. The second one is around the challenges for the growth of oil. And so on a global basis, the outlook for oil is somewhat uncertain. Going forward, we would expect, with an increasing population, that would increase the demand for fuels such as gasoline, aviation fuel, diesel, etc. However, the counterbalance to that is the ever-increasing fuel efficiency of our vehicles and a push to electrify our transport systems. And so the long-range outlook for transportation fuels is somewhat fuzzy as you go out towards 2050. It may go up, it may stay static, and so how do we account for that? And the fact that Alberta sits on the third largest oil reserves on the planet, almost 200 billion barrels. Most of Alberta's oil is in the oil sands, and it's in the form of bitumen, which is a heavy form of oil. And it has very unique characteristics that lend itself to potentially other products and not just transportation fuels. And so one of the strategies that was considered that we think is a robust strategy is to look at non-combustion products from our bitumen, because that would be a way to hedge against any potential uncertainties in the future that may exist with demand for transportation fuels. Next slide. And so the initiative itself is really based around four concepts. The first being a diversified use of our bitumen in non-combustion products, and we're really looking for high-value, large-scale, large market products. And the reason for that is there's a significant amount of bitumen that's produced on an annual basis from the oil sands. And so to meet those demands for that large-scale bitumen, we need markets that are able to receive large amounts of product. that also dovetails into accommodation for any increasing bitumen production and any newer expanded products or markets. Now, central to all this and to this program is that we're able to reduce greenhouse gas emissions associated with the end use of bitumen products. And so instead of burning it, the carbon is trapped in a solid form in different types of materials or goods and should not be released to the atmosphere where it would be a greenhouse gas. And the final pillar here is addressing any uncertainties in the future markets that may exist for petroleum fuels. And so conceptually, this is what the Bitumen Beyond Combustion initiative is. And so for a moment now, though, I'd like to take you through and talk about what that might practically look like for you on the webinar in your daily lives. How will you interact with these BBC products once they're created? And so I'd like you to think about and imagine a BBC future. So imagine you're driving home from work one day. You have a 10-minute drive, and the first thing you come across is a wood construction of a new condo project. And you look at these wood panels, and they may just look like wood panels, but they actually have carbon fibers in them. And those carbon fibers are going to add more structure and durability and long-term stability to this housing complex. So that's your first touch point in the first minute of your drive home. As you drive along further, you're driving on that asphalt road. That asphalt road is actually made from petroleum products from bitumen. Today, the majority of asphalt is not made from bitumen. But in the future, we believe that the asphalt from bitumen can provide significant benefits to asphalt. And so there's your second touch point. On your entire drive home, you're driving on that road made of bitumen. And you see some wind turbines on the side. And those wind turbines, at the bottom of them, there's a battery bank. And that battery bank is made up of vanadium flow cell batteries. And that vanadium is actually extracted from bitumen. And so there's your third touch point. So in the first 5 minutes, you've had 3 touch points on your drive home with a Bitumen Beyond Combustion product. And the final touch point is, as you make that drive, you're sipping on your iced cappuccino or your Slurpee through a biodegradable plastic straw. And the carbon in that biodegradable plastic straw came from bitumen. So there you go. On your 10-minute drive home, you've now interacted with 4 different BBC products. So from a practical perspective, that's how we envision the interaction of all of you on the webinar with BBC products in the future. That's the dream, that's the vision that we have of how we can transform our natural resource into products. And so that was really a look into the future. But I just want to shift back now and explain to you how we got to where we are today. So the concept of BBC that originated back in 2016 with a workshop hosted by the Bowman Centre for Sustainable Energy in Ontario, along with Alberta Innovates. And the exploration in that workshop was around potential non-combustion uses of bitumen. And from there, then, AXL Meisen was commissioned to conduct a phase 1 study, a foundational study that really looked at what the opportunity is and what the potential products could be. And the work out of that phase 1 study led to phase 2, which Stantec led, and Nathan will talk about that later on in this webinar. And that really narrowed down the focus from the 12 or so products that came out of phase 1 to the 5 products that we now focus on as part of this initiative. And based on the 5 products that Stantec identified, Alberta Innovates launched an open call for small-scale R&D projects that will help to advance these promising BBC products towards reality. And that was in April 2018. We just closed it in September, and we'll be announcing our decisions on that open call in the very near future. And so that's how we got from essentially the starting point to where we are today. Before I pass it off to Nathan, I'm going to talk about phase 1 and the work that AXL did. So as I mentioned, this was a foundational study really around looking at what the strategic drivers are for these Bitumen Beyond Combustion products, what are the advantages and benefits to the province of Alberta and to Canada for doing this, and what the characteristics of oil sands and bitumen are, specifically that impart a strategic advantage to Alberta and to the bitumen producers to pursue these types of products out of our oil, out of this type of oil. And so from that, a map of potential products was created. And you can see the products on the right-hand side of the screen. They cover a wide range of different areas, from asphalts to carbon fibers, graphenes and composites to polymers, and also metals. So a wide range of potential products could emerge, and all of these were examined in the lens of a 2030 timeframe. What do the markets look like in 2030? This is a longer term project because we do have to develop the technologies to get us there for these products. So the 2030 lens was used to examine these products. And so that was really the key takeaways from phase one. And that's when Stantec came into phase two. And I'm going to pass it off to Nathan now, who'll take you through their work and the foundational information they provided to this initiative.
Thank you very much, Paolo. And as Paolo was alluding to, Alberta Innovates retained Stantec to coordinate the phase two study here. And one of the critical aspects of the phase two study was putting together a collaborative team. So here's a list of the team players here. And as you can see, there's an international chemical company, a multitude of oil sands companies, the federal government, and also the Bowman Centre for Sustainable Energy based out of Ontario. So there's a very wide range of collaborators here, and that enabled us to go forward. And let's have a look at our phase two objectives. So what were we looking for? We were looking to really take this forward from phase one with a more in-depth assessment of the North American and global markets. Are these products that we're looking at, are they growing? Are they staying the same? What are some things that are holding them back from growing on a much larger scale? And in order to produce these products, what were the type of different technologies we'd have to use to take it from oil sands or a bitumen base to these products today, and whether or not there was gaps, whether or not it was possible today, and we made some technology readiness assessments on that. Of course, there's a business angle to this, looking at the capital and production cost estimates of taking this from a bitumen-based product to a new product like Paolo had alluded to. And something that was really critical was determining whether this was a near-term, medium-term, or a long-term time frame. In this context, the long-term time frame working back was about 2030. The medium-term was around about 5 years from now, and the near-term was within 5 years. So understanding these different products. And lastly there, whether or not the product would be produced in Alberta or somewhere else in Canada. So from a phase two perspective, we really had to take this on and get more focused on what was really the products of more potential. In order to do this, we designed a 4-stage process, and I'm just going to go through that right now. So the stage one, with the team members that we had an information gathering session where we built a spine of what we call a mind map of all the different options, and I'll talk about that on the next slide. So we built the information that we needed in stage one. Stage two is what we phrased the decision analysis midterm workshop. So where we defined a methodology where we'd go from the wide range of different options to what were really the best options for us to carry forward. Stage three, a more in-depth techno-economic analysis, where we actually went into depth and looking what we could actually do, what the real manufacturing costs could be, and various different aspects. All this was rolled forward into a study report that's available on Alberta Innovates website, and it's also on the last slide of this slide deck. So we had a very simple process here, essentially a screening process to get us down to the products that we needed to assess. So let's have a look at the range of different products that we had. So we come through oil sands here, and the mineable and the in situ pathway. Applying a process technology, we broke it out into a number of different sections, number of different products. Organic, from asphalt to polymer modified asphalts, a range of different items there, and we very deliberately broke out carbon fiber into two sections, a microcarbon fiber and a nano world of graphenes and nanotubes. And at the next webinar on the 28th of November, we'll talk about that in a lot more detail. The next section we have was inorganic, a range of different metals here, and the asterisk indicates a mineable only element here. Combination products, as Paolo alluded to earlier, where carbon fiber itself can be introduced and incorporated into construction components such as reinforced steel or reinforcement in wood and so forth, perhaps even in asphalt. And lastly, we looked at this from a future global products. What is the world really going to need going forward? And for sure, we centered a lot of our discussion and our findings around the construction industry. So in order to take all of those products, various different products, we apply what we call a screen, or more technically described, an analytical hierarchy process. In here, we developed assessment criteria that we applied against all these different products. And these, for example, were production, how we'd actually produce these products. What are the markets for these products? Are they growing? Are they shrinking? Do they look promising? What is the technology readiness level? And we use the Government of Canada ranking criteria. What is the technology readiness level to take the bitumen to this final product? Where is that at? How we can potentially manufacture this in Alberta or perhaps in other parts of Canada. We looked at the social acceptance, and let's talk about that for a second. It was very important for the team, and we felt that it was a critical element of the assessment criteria that if we produced a product, that it would be acceptable, an acceptable product, something that we would all want and need, and we didn't want to go down a road where we'd be producing a product where there was going to be some resistance. I'll couple cost and economic business case together. So what are the unit costs to manufacture that item? What would be the capital cost for the facility to produce that? And what does the economic business case look like for that? Last but not least, we looked at the environmental net effects score. So the GHG element with producing the component, the water and air quality for that. What we did then was we did what we call a forced ranking of the assessment criteria against each other for a weighting. So as a team, we determined which one of those assessment criteria was the most important. We also had a scoring methodology that we applied for each one of these products. And this was all conducted in a day-long workshop in October 2017. So from the data gathering perspective of mapping out all the different products and options, applying this decision analysis process, we selected 4 major products for a detailed review. So these products were carbon fiber and the combination products, asphalt, vanadium flow batteries for electricity storage specifically, and the wide framed polymers. So let's talk about those now, and let's go to carbon fibers. Carbon fibers. This is a universal product with many different applications. So if you look on the images as they appear on the screen here now, you've got a range on the left, far left-hand side from modern city infrastructure, on construction, applying to vehicles on the road, all sorts of different structural elements there where carbon fiber is now starting to penetrate. Aircraft with a number of different components that are now having carbon fiber elements, and indeed aircraft manufacturers would ideally like to move to a full carbon fiber aircraft. Down to vehicles on the left-hand side, you can see these are major global components, and in the middle strip, more bespoke carbon fiber items there. One of the reasons why carbon fiber is so interesting, it has very desirable physical properties. As a minimum, as a rule of thumb, half the weight of steel and twice the strength. And in many cases, those numbers can even be more desirable. So the production of carbon fiber right now globally is 80 to 100,000 tons per annum, with a compounded annual growth rate of about 13%. So it's growing robustly, but it's really from a relatively slow base. This market's certainly growing with 13%. But the potential is really there for a rapid market growth, and I'll align that with the next slide here shortly. The feedstock to create carbon fiber, manufacture carbon fibers right now, is petroleum feedstock based. So one of the things we did in our in-depth techno analysis here is we mapped out 2 pathways that we can manufacture carbon fiber from oil sands. And the 2 pathways here I'm going to briefly discuss is off the top of the barrel. So when we have a delayed coking process. For example, in oil sands, we have crack gases. It's the end of the cracking process, the hottest temperature. And within the off gases is a significant component of propane. So globally right now, there is propane to polyacrylonitrile to carbon fiber is a commercial pathway that's currently producing carbon fiber. The pathway that was of more interest to us here was from the bottom of the barrel. So on the oil sands characteristics that we were working on, the aspect that makes oil sands bitumen unique, as we say, is the elements of asphaltenes that are in the bottom of the barrel. So this element of asphaltenes, which is a complex form of carbon essentially, we mapped this pathway, and there's a number of different entities. So the two different ways carbon fiber is made right now is from, as I mentioned, a propane route, and also what is loosely defined as a pitch pathway to carbon fiber. Pitch and asphaltenes have some similarities. So this was a pathway that we wanted to explore further. We felt that this was of significant importance to oil sands. So in order to really have a market grow from 100,000 to millions of tons per year, we really have to hook the product into a much larger global products. So today, carbon fiber is mostly, as you'd associate it with sporting goods and specialty items, perhaps some higher end vehicles. But in order for the carbon fiber production to really take off globally, we need to have this integrated into various global commodities. So if you look on these images on this screen, being able to build multi-story buildings from carbon fiber inserted wood, that's clearly a global commodity. The vehicle down the left-hand side, that doesn't have to be a high-end racing vehicle, it can be any vehicle. We read literature that alluded to if the price of carbon fiber could reduce by up to 50%, then it becomes extremely incentivized to become as a rival to steel in all of our vehicles, and we can imagine what that would do to the growth of carbon fiber. We look at steel rebar in that picture here for concrete work. Around the world right now, people are using what we call chopped carbon fiber in place of steel rebar for a lot of applications. Again, another global massive product. And the last image there is to represent the construction industry and the assembly and manufacturing industry. So really bringing carbon fiber into this world is really what's going to take it from being 100,000 relatively bespoke high-end market into something that's really a true global commodity. And just as perhaps a small number that we'll get into in the next webinar, we calculated if 1% of the steel industry could be replaced by carbon fiber by 2030, 1% of the global steel industry by carbon fiber by 2030, that would equate to 500,000 barrels a day of asphaltenes from the oil sands if we were able to make that correlation. That's a very significant number. That's for 1% of the steel market, never mind getting into vehicle market, reinforcement market, or getting into wood market. We'll go into that in a lot more detail in the next webinar. Asphalts, or specifically the transportation of asphalts, is what we looked at in depth in the in-depth techno analysis. Currently, asphalts have to be shipped in molten form in rail cars in excess of 150 degrees C. It could be a rail car or a truck. And there's a challenge with that. For example, if we loaded up in Fort McMurray, Edmonton, and transported that to Vancouver for an overseas market, that molten asphalt would cool down and would set up. It would then have to be steamed out. A rail car would take anything up to between 12 and 24 hours to be made molten again, to pump it again, to go on a special ship. So you can see the challenges with getting a molten asphalt to different markets around the world. The markets around the world, it's a huge, large global market, and think about all the roads that we drive on every day. This market on an annual basis is worth $50 billion. It's a growing market with a compounded annual growth rate of 4%. The market's due to grow the most up until 2030 here in North America with our long roads, and also through Asia. Beyond 2030, the market is expected, although it's a fuzzy picture, more through Asia and then potentially into Africa. Absolutely large, massive continents that are going to require asphalt for many years to come. This is a very valuable commodity. Some average prices above $400 a ton. And as we talk about this in the future webinars, we'll analyze those numbers, and this is a very attractive number. One aspect that we went into some detail, but it still needs further work, is oil sands bitumen may well be a premium feedstock for superior asphalts. One of the challenges with asphalts around the world is something we'll all be familiar with, is cracking and pitting in roads on the top left-hand image here, and roads continuously needing to be repaired, and all those annoying things that we have on our drive home is quite often linked to repairs on asphalt. So we feel that the consistent qualities and characteristics of bitumen may well give us a superior asphalt. So what's essentially needed here is a methodology for bringing asphalt into a solid form, whether that be a ball, a puck, or whatever shape, perhaps even in a lump of coal shape, that we could put into rail cars and utilize existing infrastructure. Coal, for example, is probably the largest by bulk commodity that's moved around through marine ports around the world. Going into the future, we expect coal to be moved less. It would be excellent here in North America or Western Canada if we could start to utilize that infrastructure with asphalt in a similar shape and form. So that's the work that we've been doing. Next one's very, very interesting, as Paolo alluded to earlier. Vanadium. Vanadium is currently the leading flow battery technology. Very briefly, what we mean by that is, in our cell phones and so forth, we have a solid state technology, often lithium. But when we want a battery of a very large capacity size, we move to what we call a flow battery. So this is a liquid battery. So the vanadium itself sits in what we call an electrolyte in two different tanks. And the ionic exchange between those two and a fuel cell, that's what provides the power at a very high level. So what we know about the flow battery market is vanadium is the leading technology to date, and it's emerging, could change, but it's the leading technology in the flow battery market. This is a global market, as you can imagine, that's growing rapidly from a small base. These numbers I pulled from Bloomberg on 5 gigawatt hours installed in 2016, reaching more than 300 gigawatt hours by 2030. This is rapidly becoming out of date. This market is growing very significantly. And the reason why is this is tied to renewable energy viability. What we mean by this on this image on the left-hand side is, for example, we have the solar panels and the wind turbines. The solar panels, during the day at the moment, they generate power from solar, and they provide that power out. When the sun goes down, we're unable to provide power. Similar when we have wind with the wind turbine, when the wind goes down, we don't have a means to do power. So in these kind of shipping containers here, this is where the tanks of the vanadium electrolytes sit. And what happens is we're able to charge the vanadium flow batteries, so when the sun goes down or the wind goes down, we have a charged battery storage. So this is the essence of the vanadium flow battery. So it enables us to smooth out the renewable energy viability, which is probably its largest constraint at this point. What's the oil sands connection to vanadium? Well, in a barrel of bitumen, the vanadium content is approximately 200 parts per million. Extracting that straight out of a barrel of bitumen, very, very challenging. To date, one oil sands operator has a process whereby they were extracting the asphaltenes, and then they were also gasifying the asphaltenes to leave them with a fly ash. The fly ash then was a highly concentrated form of vanadium. So there's various different elements of the oil sands cycle, and we allude to this in the report, where you can start to concentrate the vanadium for extraction. However, what we will say is, although vanadium is very enticing and has tremendous potential, extracting vanadium from its different parts of the oil sands and bitumen cycle is going to be a challenge. Not to say it's insurmountable, but nonetheless a challenge. On to the last one. Polymers. What we mean by that is polymers, plastics. Of course, this is a major, diverse global industry. And I should imagine as people sit around their offices around different parts of Canada and and the world, people dialing into this, if you look around your room, you'll see a number of different plastics around your room. This is the polymer industry globally. It's an absolutely massive market. Depending on how you define what's a polymer, this market, from our definition for this purpose, is currently a $600 billion US market, and it's growing to closer to $1 trillion a year market in 2030. Considering the size of this market, it's still growing very significantly, a compounded annual growth rate of 5%. So for us to start looking at bitumen and its pathways into polymers, it's a challenge. There's high barriers to entry. We're talking about global companies that produce these plastics that you're probably looking at in your office. Tremendous amount of intellectual property, and there's a long history of people refining these processes. So there's a significant challenge there. So oil sands, and the major challenges for polymer market globally, even though I alluded to the fact that this is a massive market, I think in the last 12 months, I think all of us could attest to reading stories about a real global attention around plastic pollution in oceans, not going to the restaurant and having a plastic straw in your drink anymore. This market is changing, so we see that as a potential opportunity. The market is moving to more biodegradable, compostable polymers, so this big market is having to change. With that change is perhaps an opportunity. So oil sands connection to polymers, that's really going to be going through what we call the refining route, and there's work needs to be done on that. We do think it's a challenge, but nonetheless, with the market size of that large, going through significant changes, it's something that needs to be pursued further. And to talk about some of the challenges and the questions going forward, I'm going to hand you back to Paolo to lead you through to the rest of the webinar.
Thank you, Nathan. So Nathan and I have taken you through this BBC journey, essentially from inception to where we currently are, and Nathan took you through the four and a half with combination products, different product areas that are of great interest. But as has been intimated throughout this webinar, the products we're talking about won't be ready tomorrow, right? Unfortunately, we can't go to the bitumen mine and pull out bitumen and pull out carbon fibers or plastics straight from the raw material. They actually need to be processed and made. And so there are some key challenges and questions to ponder around that as we activate this BBC future. So what I'd like to ask all of you listening on the webinar today is to, as we go through these challenges and questions, to maybe reflect on them and think about how you or your organization may be able to play a role, because the solution and the success of this initiative really, I think, will be from all of us. Every one of us will bring something to this initiative. And so the challenges that we see, the overarching challenges right now, are split into technical and market. The technical is really about how do we get these products made from the raw bitumen itself. Right? And so the first challenge that comes out, and Nathan alluded to this, is how do we extract those feedstocks, those starting points to make these products? They could be carbon molecules, they could be metals. That is one of the challenges, because as we know, bitumen is a mixture of many different components. But once we have that extracted, how do we turn those into the prototypes and then take those prototypes into an actual product that we can sell? Right? There's a whole development cycle there that also needs to be thought through and worked out, and there's a lot of science and engineering that will need to go into that as well. Underpinning all of that is the technologies and the equipment that will process these materials and make these products. And some of those may need to be adapted from existing, but some may actually be created new. So there's opportunities there as well to contribute to this area and to this challenge. Once we make these products, of course, they need to be sold into the market. Well, the market has to be ready to accept them. So in parallel with these technical challenges, we're also thinking about what are the pathways to commercialize these products, so that once the products are ready, they can be readily accepted into the market. One of the key challenges that will have to be addressed is economic competitiveness. These products have to be economically competitive with those today, or even better on economics. And so that's a challenge that we'll work through as we develop the products from a technical basis. And so from these challenges, then, questions arise. So the questions, the big questions, and there are more questions than the ones I've listed here, but we've decided to focus on these key questions. really, how do we extract those feedstocks? That's one of the biggest questions we have right now. We need those starting materials, those feedstocks to be in the right form so we can make those products. So that's a big challenge that we're looking to resolve. From a market perspective, how do we enable the markets to uptake the BBC products? What information do buyers and sellers need to know? Will they want to consider about these BBC products before they make the decision that, yeah, we're going to sell these into the market? We want to address those before we reach that point that the products are ready. And finally, there's a lot of smart people on the line today, great people. What other products have we not thought of? Right? We don't have all the answers, right? So what other products have you thought of while listening to us today saying, hey, we could make that out of bitumen. That's a great idea. We want to know. So please drop us a line, let us know what some of those other products might be that we should be exploring and considering as we move forward with this initiative. And so with that, I'd like to just take a step forward and talk about our next webinar, which will be on carbon fibers. And so Nathan talked a little bit about carbon fibers earlier, but we're going to take a much deeper dive in on that next webinar. We're going to look at how carbon fibers could be the material of the next century. That's what they've been coined. And for the reasons that Nathan alluded to, how they can integrate in different areas of our economy and society. We're going to talk about the markets, how they're made, what the costs are, and what the connection is with oil sands bitumen, how we can take bitumen to a carbon fiber future. And also what Alberta Innovates is doing in this space as well. And so that webinar will be on November 29th from 10 to 11 Mountain Time. Registration is now open, so we really hope you register and really hope that you're able to join us because it's going to be a great conversation about this fantastic material, really exciting. And so with that, I'm going to pass it back to Peter to wrap us up for the presentation.
Okay, well, thanks both Paolo and Nathan, and apologies, we had Axel on the line. Obviously, that the technology didn't work for us at the moment, but I would open it up to questions. So again, for those of you who are interested, please text them into the system. We will pick them up at this end, and we'll wait a moment for questions to arise or to come in. For those of you who do want to see a copy of the report, we are giving you the link here. And again, if you're not able to link on this, to be honest, if you just go BBC, Bitumen Beyond Combustion, and Google it, it comes right to this report. So it's right there. We are waiting for questions to come in. I will ask, I guess, to Paolo. I know in this in the presentation you mentioned part of the phase one was the $2 million activity that you're doing. Can you just tell us a status of where that is? Where is it?
Absolutely. Yeah. So we opened a call for proposals to advance different BBC projects back in April, and we worked through both an expression of interest and full project proposal phase with different applicants. We've concluded our review process, and so now we are just and have selected a number of projects to go forward. We're just in the contracting phase, and once the contracts have been finalized, we'll be announcing those that we have selected.
Okay.
And we expect that in the next month or so.
Great. Okay. So, and just, it was oversubscribed. I remember you mentioning that. There was quite a significant amount of interest.
Yes, there was significant interest in this call. Yes.
Great. Great. Okay, so we're just looking at the list of questions. There's nothing coming in at the moment. So again, if you do have specific questions, or we do see that people are writing.
Yes.
So, you go ahead.
Our first question, are you working with experts in the fields of your 4 target products, i.e. talking to Nova Chemicals about polymers?
From our perspective, yes. I wouldn't say necessarily, I wouldn't comment on Nova. We had a member of the team at Stantec who was with a global polymer manufacturing company. And we had those insights into the phase 2 report. There's some ongoing dialogue with Alberta Innovates where we're bringing that intelligence into the polymer equation. The polymer world is changing. There's a lot of pathways from crude oil, but also a lot of pathways from gas right now. So we are talking about that, but I think we really need to set our path forward, and it's really going to be Alberta Innovates who's going to be making that.
Yeah, and from the Alberta Innovates perspective, as we move forward, we will absolutely be engaging. We have been engaging and will be engaging with experts across all these 4 areas in particular. And once from our open call, we did receive interest from experts from across all four of those areas. So there's absolutely interest, and we absolutely want to keep those discussions going with experts from all those areas, because that will help us position these products to ensure that they're able to be received into the market once they're developed.
Another question, should environmental considerations have been included in the selection process?
They were. We had two different aspects there, environmental net effects and also a social acceptance. So in the environmental net effects, we examined, for example, if we were going to produce asphalt, what was the net effect on GHGs of producing asphalt. We also examined if there was a water effect and if there was an air quality effect, and a number of other aspects. For example, on vanadium electrolyte, what was the environmental net effect of a landscape having lots more vanadium electrolyte? So that was, when we looked at our assessment criteria, environmental net effects and social acceptance was very high up on our weighting scenario. So we evaluated that, yes.
Thank you. Biodegradable polymers versus recycle of polymer. Are you encouraging more focus on biodegradable over recycle of polymers?
I think there's biodegradable polymers, recycled polymers, compostable polymers. It's quite a complicated equation. So we did have some discussions with Alberta Innovates during the end of this Phase 2 report on some different routes to purely biodegradable polymers, where I can tell you, and our international chemical company, BASF, involved in this, alluded to, this is a complicated area, and understanding how we belong and what our pathways are there. So to answer the question is, it's under consideration, and I think Alberta Innovates is trying to find the right path again there.
I think, and the other element to that is the chemistry behind biodegradable polymers maybe is different per se than in some other materials, plastics that may not be biodegradable but may be recyclable. So I think it's a little bit of both.
Yeah.
Right? There are some polymers you just can't biodegrade because they don't have the right chemistry to them, and you could recycle those, whereas others you can biodegrade, and conceivably both could be made from bitumen feedstock.
Okay.
We just had a comment to follow up with that. Biodegradable plastics become CO2 or CH3.
Yeah, there is a life cycle analysis that needs to be done on that.
I note that in the area of polymers, there is a startup called Genesis in Canada working on producing degradable polymers from agricultural waste. Thank you for the comment.
Yeah, Genesis, we haven't spoken with them, but just as work outside of Alberta Innovates, we discussed with an international company on renewable feedstocks for biodegradable polymers. As I alluded to in the presentation, the market's so big and it's changing. There's all sorts of different things, exciting things from a technology perspective that's going on there.
To what extent would these new products rely on existing production chains or infrastructure? Are economic projections based on these technologies being supplementary to existing interactive operations or independent?
Yeah, so what we did was, and you can have a look in the Phase 2 report, for each one of these products, for example, carbon fiber, we showed a basic flow diagram of how we go from our existing process, where we take a feed stock, where we take it from in the process, what temperature pressure it was, and what type of process we need in order to convert that, for example, into a carbon fiber. In that particular case, that's quite an intensive manufacturing process. A much easier one is taking part of the oil sands production cycle, and again, this is in the report, and making an asphalt. That's a much easier and simple process. So yeah, we looked at that, and the process flow diagrams at a high level of how we produce that are in the Phase 2 report.
And then I would say, to add on to that, to the extent possible, we would love to leverage existing technologies and existing processes to not reinvent the wheel. But the science and engineering behind developing these products may necessitate a shift to different processes or technologies.
Asphalt is already manufactured from Western Canadian heavy oil. What is different here? Is it just the solidification of asphalt for transport?
Yes, essentially. It's being able to reach markets further than where the heavy oil asphalt market is currently able to reach. So we did some work in the Phase 2 report on potentially markets that we could go to by not having to have the asphalt solidify and remolten all the efforts and energy intensity. So it's really about putting it in a different form to ship it further distances.
Some products such as asphalt are essentially byproducts of fuel production. As world demand for fossil fuels decreases, this should create opportunities for supplying these products from elsewhere. Comments on impact of bitumen future?
You want to take that?
Can you
Repeat
that question?
Sure. Some products such as asphalt are essentially byproducts of fuel production. As world demand for fossil fuels decreases, this should create opportunities for supplying these products from elsewhere. Comments on impact of bitumen future?
Well, to that I would say it's the products that we're targeting. I mentioned earlier that bitumen has unique characteristics, and one of the unique characteristics is, so for example, is a much higher carbon content than other oils. And so that lends itself much more favorably to the production of, for example, carbon fibers or carbon-based products, because there's more carbon present initially and less hydrogen, there's less waste and byproducts from that process. So strategically, oil from bitumen has that advantage, where regardless of the production of where transportation fuels may go. One of the long-term visions that I think we have, as well, is to also look at the lighter end of the barrel, as well, the longer chain, or the lighter ends essentially. Can we also use those in the conversion process? And so that way we can maximize the use of the barrel towards non-combustion products to hedge against any future uncertainties that the author is alluding to in that question.
CN Rail has their bitumen pucks project for transport. Is this applicable here?
I think it is. I think although that's for bitumen, the idea of bringing a bitumen, which bitumen would be more difficult than asphalt, but it's applicable in that space of palletizing or putting it in a enclosed, sealed atmospheric temperature. It's related. It's in the same context. Yeah.
That's the last question we have online at the moment.
Okay, we'll give it a minute. Just a reminder, well, I did want to ask Paolo one question, because you said, if you do have good ideas or, let us know. So if, someone sitting in the audience has an idea so what should they do?
Feel free to reach out to me directly or Axel. You can even pass it on, or Nathan as well, and we'll share obviously any of those comments amongst us, and so that we can and then get in contact with you and have a conversation.
Okay, we do have one more question. Two more questions. Oh, they're starting to come in now.
You have outlined a potential future based on a starting point of what we know today. As part of this initiative, is there a complementary process underway that looks for opportunities we might not currently envision today?
Go ahead.
So I will take the term opportunity to mean other products from bitumen. And so we are always thinking of potential other products and what the next steps might be. And so in that sense, it's continuous and ongoing. And so I would welcome any thoughts or any considerations anyone has towards what other opportunities might exist. To again reach out to us and let us know. We're always open to hearing new ideas, so that we can further maximize the value from bitumen in the province.
Last question. Has carbon pricing, both in Alberta, in Canada, and abroad, been considered in the economic evaluations for these technologies?
I would say not yet. We did a more in-depth techno-economic analysis in stage 3 here, but I think, and we basically did some calculations on what the net effects of, say, producing carbon fibers was by a tonnage on the impact on carbon. GHG, but we didn't do an in-depth calculation to that effect. We were really trying to ascertain whether this was a carbon-intensive process or not.
Okay, thank you. That's all we have at
Okay.
the moment.
That's all we have at the moment. I just wanted to remind everybody that we do have the following webinar, right, which will be November 29th, and the topic is?
Carbon fibers and uses.
Yeah, and the intention is to do a few more after that, but starting with that one on November 29th, it is available on
Eventbrite.
Eventbrite, yes. And we will be sending you, each of you who did attend the call, we did want to send out a survey and to get an understanding of, was this enough background detail, or what more did you want? Because the next discussions are going to be fair, they will be a little bit more technical and a little bit more economic assessment on each of the product sets. So carbon fiber being the next one. But we just wanted to get a sense of, was this beneficial, et cetera. So please look for that. If you could let us know, please respond to that in the next couple of days. So we'll use that to feed into the next presentations. So on that, I would like to thank our presenters, both Nathan and Paolo, as well as Axel, who tried, but hopefully next time. But again, thank you very much, and look forward to talking again soon. Thank you.